Ibn Al-Haytham Biography. Ibn Al-Haytham, a physicist, mathematician, and astronomer from the Islamic Golden Age, is renowned as the father of modern optics. Born in Basra, he dedicated a significant portion of his life to the Fatimid capital of Cairo, residing near the esteemed University of Al-Azhar. Sustaining himself through the proceeds of his literary endeavors, Ibn Al-Haytham made groundbreaking contributions to the principles of optics and visual perception. His most influential work, titled The Book of Optics, 10th to 11th centuries, laid the foundation for the modern science of physical optics. This seminal work was not only pivotal in its time but continued to influence renowned scientists such as Isaac Newton, Johannes Kepler, Christian Huygens, and Galileo Galilei during the Middle Ages. Ibn Al-Haytham's theories on cosmology were translated into various languages, including English and Latin. Ibn Al-Haytham's scientific method. One of his key achievements was the correct explanation of the theory of vision, asserting that vision occurs in the brain. Additionally, he significantly contributed to catoptrics and dioptrics by delving into the study of reflection, refraction, and the nature of images formed by light rays. Notably, Ibn Al-Haytham championed the idea that hypotheses must be supported by experiments and mathematical reasoning, a concept embraced 5 centuries before Renaissance scientists did so. His legacy endures as that of a pioneering figure who shaped the trajectory of optics and scientific methodology. Book of Optics. The Book of Optics, which was written between the years 1011 and 1021, was a groundbreaking book that established the principles of physical optics as we know it today. Ibn Al-Haytham, or Al-Hassan, was a prominent medieval physicist and scientist whose work was acknowledged by Galileo Galilei, Johannes Kepler, Christian Huygens, and Isaac Newton, among others. His cosmological writings have been translated into languages including English and Latin, demonstrating the influence of his beliefs even after his death. Ibn Al-Haytham was the first to precisely describe in his investigation of the theory of vision that vision arises when light reflects from an object and then reaches the eye. He further argued that vision is a personal experience that varies from person to person and is subjective. Notably, he defied conventional wisdom by claiming that vision occurs in the brain. Ibn Al-Haytham's achievement. His significant achievement in optics was the development of a theory that harmoniously combined elements of Euclid's mathematical ray arguments, Galen's medical tradition, and Aristotle's intermission theories. Ibn Al-Haytham addressed the challenge of each point on an object corresponding to a single point on the eye. He proposed that the eye perceives only perpendicular rays from an object, emphasizing their strength over oblique rays. This conceptualization, outlined in the 7-volume Treatise on Optics, Kitab al-Manazir, marked a pioneering effort to resolve optical complexities. Ibn Al-Haytham's theory. Ibn Al-Haytham's theory, detailed in the 7th book of the Optics, suggested that other rays would be refracted through the eye but perceived as if they were perpendicular. This innovative approach to optics was unparalleled at the time and proved highly influential, particularly in Western Europe. The theory sparked significant advancements in optics from the 13th to the 17th centuries, with Johannes Kepler's theory of the retinal picture directly building upon the conceptual framework established by Ibn Al-Haytham. His enduring legacy underscores his profound impact on the development of optical theories and scientific thought. Theology. Ibn Al-Haytham, a Sunni Muslim, authored a book titled Finding the Direction of Qibla by Calculation, wherein he discussed the mathematical determination of the Qibla, the sacred direction towards the Kaaba in Mecca, Saudi Arabia. This direction holds significance for Muslims in various religious contexts, particularly guiding the orientation of prayer during Salah. Unconscious interference. In the exploration of unconscious interference, Ibn Al-Haytham articulated a perspective wherein the organ does not immediately sense the forms originating from visible objects. Instead, sensory perception occurs subsequent to the organ being influenced by these forms. This implies that the final perception of color and light takes place at a time following the arrival of the form from the surface of the organ to the cavity of the common eye. Ibn Al-Haytham's insights into this process shed light on the temporal dynamics of visual perception, emphasizing the intricate interplay between external stimuli and the internal mechanisms of the eye. Color constancy. Ibn Al-Haytham expounded on the concept of color constancy through meticulous observation, highlighting that the light reflected from an object undergoes alterations based on its color. He emphasized the intermingling of the quality of light and the object's color, with the visual system tasked with distinguishing between them. In Book 2, Chapter 3, Ibn Al-Haytham reaffirmed that light and color are inseparable, clarifying that the transmission from a colored object to the eye involves both elements mingled together. Despite this fusion, the perceiver discerns the visible object as luminous, effectively differentiating between light and color and recognizing them as having distinct properties. Ibn Al-Haytham's profound insights into color constancy showcase his astute observations and systematic comprehension of the intricate relationship among light, color, and perception. Legacy. Ibn Al-Haytham left an indelible legacy through his significant contributions to optics, number theory, geometry, astronomy, and philosophy. Honoring his achievements, a lunar impact crater was named after this Arab Muslim scientist, called Al-Hassan, situated near the eastern side of the moon. His enduring impact is further underscored by his representation on the Iraqi 10,000 dinar banknote issued in 2003 as well as on 10 dinar notes from 1982. In 2015, the International Year of Light, organized by UNESCO, commemorated the 1000th anniversary of Ibn Al-Haytham's influential works on optics. This celebration served as a testament to the enduring relevance and profound impact of his contributions in various fields. Conclusion. H.J. Winter, a respected British historian of science, concisely outlined Ibn Al-Haytham's significance in the annals of physics. Winter noted a conspicuous void in the emergence of notable physicists from Archimedes to the era of Ibn Al-Haytham. Centering on the history of physics, Winter underscored a transformative span surpassing 1,200 years. During this epoch, the Golden Age of Greece gave way to Muslim scholasticism, wherein the experimental fervor reminiscent of antiquity's noble physicists found renewal through the scholarly endeavors of Ibn Al-Haytham, an esteemed Arab scholar hailing from Basra.